Here's a prokaryotic cell. Cells need to make energy to live. Metabolic reactions help a cell to make this energy. This is oxidative phosphorylation, in plain English. What is oxidative phosphorylation now? Well, oxidative phosphorylation is a process where microbes oxidize nutrients to produce ATP. But what is ATP? ATP is the main source of energy for cellular functions. ATP is consumed by the cells in energy-requiring processes. Basically, you can think of ATP as a coin. Cells are kind of like a carousel. You basically put the ATP coin in and the ride takes off. In the same way, ATP powers the machine that is the cell. Cells go through a series of respiratory steps. Oxidative phosphorylation is the final step in the cellular respiration, following glycolysis and the citric acid cycle. Oxidative phosphorylation occurs here in the inner cell membrane between the periplasmic space and the intermembrane space. Oxidative phosphorylation uses a series of oxidation and reduction reactions. An easy way to remember oxidation and reduction is oil rig. Oil stands for oxidation is loss of electrons, and rig stands for reduction is gain of electrons. When a molecule is oxidized, it loses electrons, becoming more positive. When a molecule is reduced, it gains electrons, becoming more negative. One molecule that's commonly oxidized and reduced in the cell is NADH. When the nitrogen in NAD+ gains electrons, it's reduced to NADH, and vice versa. The overall process of oxidative phosphorylation involves electron donors, electron acceptors, ADP and ATP. An electron donor starts the process. An electron acceptor is needed to finish the process. ADP must always be present. The products of the process are ATP and an oxidized electron donor and a reduced electron acceptor. Commonly, NADH is an electron donor, whereas oxygen is an electron acceptor. As we learned before, NAD+ is the oxidized form of NADH, and H2O becomes a reduced form of oxygen. Oxidative phosphorylation uses what is known as an electron transport chain. The electron transport chain consists of protein complexes that have cofactors that assist in transferring electrons. All electron transport chains have a dehydrogenase and an oxidase. Some electron transport chains utilize what is known as a cytochrome BC complex, and at the end of the electron transport chain, there's an ATP synthesizing complex called ATP synthase. The purpose of an electron transport chain is to produce energy in the form of ATP. The electron transport chain moves electrons in order to create a proton gradient, and then when the proton gradient is large enough, the protons pass through the ATP synthase and into the cell, creating energy. Heme and iron sulfur centers are common helper molecules in the electron transport chain. These helper molecules, called cofactors, assist in moving electrons through the electron transport chain. Okay, so let's go through a sequence of events in the electron transport chain. First, the electron donor is oxidized by the dehydrogenase. As the electrons pass through the dehydrogenase, protons move from the cytoplasm to the periplasm. The electrons are then passed to quinone, an assistant in the electron transport chain. If present, the cytochrome BC complex receives the electrons from quinone. The electrons move through the cytochrome BC complex, and then protons are pumped through the membrane again. After this, the oxidase accepts the electrons from the cytochrome BC complex and uses a final electron acceptor to give away the electrons. Then, the oxidase pumps more protons across the membrane. As you can see, all of the complexes in the electron transport chain act as proton pumps. A proton gradient is established by the movement of electrons through the electron transport chain. And since the cell likes to have equal concentrations of protons on the inside and out, some of the protons must move inside the cell. These protons move through ATP synthase. ATP synthase is a machine that makes ATP. Finally, ATP, our energy source, is made. A couple of variations can occur in oxidative phosphorylation. There can be different electron acceptors and different electron donors, but the process is basically the same. Some cells don't have a cytochrome BC complex, but in this case, the electrons just move from quinone to the oxidase. Oxidative phosphorylation can also be affected by the amount of oxygen present. The amount of oxygen can determine the number of protons that are pumped for each electron. Obviously, with higher concentrations of oxygen come more protons pumped per electron. Oxidative phosphorylation produces the most ATP of all the respiration pathways, which is why it is very beneficial to cells that have electron transport chains, because cells need ATP to function. This has been oxidative phosphorylation in plain English.